Welcome back. In this lesson, we are going to look at two different ways to create and access lists in Python. First, we will start with the approach you already know, using normal loops. Then we will compare that with a faster, cleaner method called list comprehensions. By the end of this lesson, you will see that list comprehensions aren't some new complicated feature. They are really just loops written in a shorter, more readable way. Let's start with the regular way. Imagine we want to take a list of numbers and double each one. We just start with a list of numbers, 1 up to 6. We create an empty list called doubled. Then we use a for loop to go through each number in the list for num in numbers. On every loop, we multiply the number by 2 and add it to our new list. Therefore, it starts from the first number and multiply that number by 2 and append it to the doubled list using append method. Then it moves to the second and do the same until it reaches to the last element in the list of numbers. When we run it, here is the result: 2, 4, 6, 8, 10, and 12. So with just a normal loop, we have transformed one list into another. Loops aren't just for building new lists. You can also use them to access the elements of an existing list. For example, let's say we have a shopping list such as milk, bread, eggs, and apples. If we want to go through each item one by one, we can use a for loop like this. For item in shopping, then print I need to buy item. The loop takes the first element, milk, and prints it. Then it moves to the second item, bread, and prints it. Then moves to the third item, eggs, and prints it. And finally reaches to the last item, apples, and prints it. Each element of the list gets accessed one by one inside the loop. Then when we run it, the output looks like this. I need to buy milk, I need to buy bread, I need to buy eggs, and I need to buy apples. So with just a simple loop, we can access every single element of a list without worrying about their positions. Alright, now that we have seen how to use normal loops with lists, let's introduce something new: list comprehensions. Think of a list comprehension as a shortcut. It is a way to take the exact same logic we wrote with a normal loop and squeeze it into a single, cleaner line of code. Here is the syntax: new list, then in square bracket, expression for item in iterable if condition. The expression is what you want each element to become. For item in iterable is the loop, just like in a normal for loop. And the if condition is optional part. It lets you filter elements, so only some of them get included in the new list. For example, remember when we doubled the numbers using a normal loop? Let's rewrite that using a list comprehension. Doubled in square bracket num times 2 for num in numbers. Then print doubled. That's it, just one line. The part before the for, num times 2, is an expression that tells Python what to do with each item in the list of numbers. The for num in numbers is the same loop you already know in the previous example, just written inside the brackets. So it just iterates through the list of numbers starting from the first item in the numbers and multiply each number by 2 and store it in the newly created list called doubled. Then when we run this, the output is exactly the same. That is 2, 4, 6, 8, 10, and 12. So, list comprehensions aren't a new concept. They are really just loops written in a shorter, more readable way. You can also add conditions inside list comprehensions. This makes it easy to filter out items you don't want. For example, let's filter out the odd numbers and only keep the even numbers. Then evens is in square bracket num for num in numbers. Here we add a condition that checks each number is even using if num modulus 2 is equal to 0. That is the remainder. Therefore, the loop goes through each number in the list of numbers 1 up to 6 and then check the condition before storing that number in the new list called events. Therefore, it starts from the first number 1 and check that 1 modulus 2 is equal to 0. That's false and ignores this number and move to the second item, that is 2. 2 modulus 2 is equal to 0. That is the remainder is equal to 0. Therefore, keeps this number in the new list events. Then move to the third element 3. 3 modulus 2 is equal to 0. That's false and ignore it and move to the next number, that is 4. 4 modulus 2 is equal to 0. That's true and keep this number as even. Then move to the next number, that is 5. 5 modulus 2 is equal to 0. That's false and ignore this number and move to the next number. The next number is the last number in the list. Then 6 modulus 2 is equal to 0. That's true and keep it as even. Therefore, only the numbers that pass this test are added to the new list called events. Then when we run this, the result is 2, 4, and 6. So in just one line, we have created a filtered list that contains only the even numbers. List compressions can even handle nested loops, which means you can replace two loops with a single clean line of code. Nested compressions are especially useful when working with real-world data. For example, let's say we are tracking student test scores across different subjects and we want to pair each student with each subject to prepare report entries. So we have a list of students such as Alice, Bob, and Charlie, and subjects such as math, science, and history. Then we create a new list called reports, which contains student subject pair. Therefore, we iterate through each student for student in students. Then in the inner loop, we iterate through each subject for subject in subjects. For each student, Python loops through all the subjects in the inner loop. It combines them into a string like student subject. Then the result is a list of all student subject report entries. When we run this, we get Alice Math, Alice Science, Alice History, Bob Math, Bob Science, Bob History, Charlie Math, Charlie Science, and Charlie History. This could then be used to generate report cards, build a grade database, or track performance, all starting from a single line of Python code. Alright, so far so good. Normal loops are great for learning. They show each step clearly. When you are starting out, write the loop so you can see how the data moves and where things go wrong. Once that logic is clear, convert the loop into a list comprehension for shorter, more Pythonic code. Just don't force a comprehension when the logic gets complicated. If it is hard to read, stick with the normal loop. And that's it. Loops versus list comprehensions in Python. Try this yourself. Take one of your old loops and rewrite it as a comprehension. Thanks for watching.